Good afternoon, everyone. Thank you for joining us. Excited to have you here with myself, Ola Westrom, and Adam Booth from Anderson Hauser. I'm Caleb LaRue. I'm an outside sales engineer based out of Kansas City, Missouri. And if you're not familiar, Vector Controls is a instrumentation and automation company based out of Houston, Texas, covering throughout the South and southeast part of the country. We have a lot of people on staff with tons of expertise in food and beverage, and trained service members that we can bring and to your location at any time that you need them. With that going, I'd like to introduce Ola Westrom.
Yeah, thank you, Caleb. Yeah, I'm Ola Westrom. I'm the industry manager covering the food and beverage segment for Anderson Hauser, USA. I'll lead you off a little bit here today, and then Adam will take the rest. Adam, it's up to you.
Yes. Thank you, Ola. So yes, as Ola mentioned, my name is Adam Booth. I'm one of our Flow product managers here in our Greenwood, Indiana headquarters. And so I hope you guys really enjoy the presentation today. We have a lot of cool material to go over. So with that, I'm going to hand it off to Ola to get us started, and then I'll join you guys here in a few. Thank you.
Yeah. All right, so I'll get us rolling here a little bit. Adam will cover the more technical aspects of the Coriolis meters, how they work and how they'll be leveraged for density and concentration measurements. Primarily, we're looking at this today for food and beverage, but many of these applications are widely applicable across many other industry segments as well. And the reason why concentration measurement is say gaining traction in the industry as a whole is as people are looking for better plant mass balance, better accounting of a product, reducing any giveaway. Concentration obviously is a very relevant parameter to keep an eye on. So not only, let's say, the volume or the mass of a product, but also the concentration. You can imagine, you know, it's like if you have a product mix and you're adding too much of one ingredient, well, then you're kind of giving away that product that hits straight down to the bottom line. So concentration measurement is directly related to plant mass balance and product loss reductions. It can also be used, and Adam will share some examples about this, for increasing plant availability. Many times concentration measurement is something that is done in the lab. So somebody have to take a sample, bring it to the lab, check it, and then decide, you know, can production continue or not. So either there's a hold time that can be reduced or eliminated, or potentially rework a product and so on can also be greatly reduced by keeping a continuous monitoring of the concentration of a product. And while they're doing this here, then for audits and recipe management and other things, you get a continuous record of all the production protocols, recipes, and so on that's going on there. And ultimately, that then brings to protecting the brand image. So there's clearly the consumers are expecting to get a certain product with a certain quality, and concentration ties very much to that. So Adam, there you go. And the basis or the foundation for concentration measurement using Coriolis mass flow meters is the density. So we look at a density of a product, of a density of two products. And this is very important to keep in mind, that you really need to be a binary type of solution you're in. So you have a carrier fluid and then the secondary one, and you're looking at what the total concentration is there. It's really not possible to do it with more than two variables in there, because then the density could be affected by that third component. So think about it: if you have two variables, then density can be used for concentration measurement. If you have other mixtures, then you may need to look at other types of measurement to get the correct measurement performance and accuracy that you're looking for there. And so subsequently, that looks for the overall performance. In the food industry, particularly, we're looking at a large number of different products. The most common one is probably Brix measurement of a concentration of sugar in syrups or in high fructose corn syrup or other type of sweetened products. brewery, we're looking at the wort extract, which is directly related to the efficiency of the brew house. We can look at fat in cream, for example, percent alcohol or proof measurement, starches, and other applications. And Adam will touch on a very exciting application here that's recently been made possible to do with Coriolis meters, and that's overrun. So we're looking at air in product, the most typical one being the amount of air during ice cream production. Aside from that, you also get into our chemical applications. If you look at concentration of various acids, caustics, and so on, where you can use density as a measurement to arrive at a concentration measurement. And with that, I will hand over to Adam to cover the more technical aspects of Coriolis and density concentration.
Perfect. Thank you, Ola. So, we're going to continue with this density vein that Ola mentioned. So, many different fluids have, varying densities depending on the, what the fluid is and also what temperature or even pressure the fluid's at. So based on this density measurement, we're actually able to determine the concentration, or in other words, the ratio of one fluid to the other, because, obviously a fluid is going to have a known density. And so if these two components change their ratio, so for example, if you have water and oil, and if the percentage of water in the oil shifts, then obviously that total density is going to change as well. So if we know the temperature and the density, and then with some math, we're actually able to determine the concentration. And then there in the picture, you can just see some pretty, everyday items, and based on their density, how they sit there in a cup. So building on this a little bit more, there's two different ways to look at concentration. So there's a mass basis and there's always a volume basis. So for example, on the left-hand side, we're looking at it in terms of a volume basis. So you can see we have two different fluids. Fluid 1 has a density of 1 grams per cc at 68 degrees Fahrenheit. And then fluid 2, you can see, has a density of 2 grams per cc at the same temperature. And so if we look at it from a volume basis, you can see that they both make up half of that mixture. But if you look at it by mass fraction, due to the lower density of fluid 1, you can see that it's actually a 1/3, 2/3 split. So the real thing here is that the volume fraction is affected by temperature. So this is when an expansion coefficient would have to come into play, but the mass is not affected by the temperature. So again, as we get into some more of these details and examples, you'll see that some of these are going to be split between mass or volume basis. And in our Coriolis meters, you can actually determine and choose which works best for your application and the process. And you can even use custom units as well. So how does this all work with a Coriolis? So for example, up on the screen is a picture of our Promass Q Coriolis sensor. And so a Coriolis meter, a traditional Coriolis meter, measures 3 different parameters. So that's going to be mass flow, so that'll be a pounds per minute or kilograms per hour. A density measurement, so that would be a grams per cc or pounds per foot cubed. And then it also measures temperature. So those are the 3 direct measurements that a Coriolis meter provides. So from these 3 values, it's possible to calculate concentration in a weight percentage, so a mass percentage, or as a volume percentage. And then some of those units that Ola mentioned earlier, like the Brix or proof measurement or degrees Plato, Baume, etc. And you'll see how this actually works inside of our Coriolis meter here in a few slides. So there's just really one main point that I want to drive home here, and Ola did mention it earlier, but if a fluid consists of more than just 2 components, only 2 of those components can change in order to make an accurate measurement. So for example, if you have 3 or 4 components, and let's say that all 4 of them are constantly changing composition, then we're not able to make an accurate measurement because we're going to be dealing with 4 different changing densities over a temperature range. So only 2 components of a solution can change in order to provide an accurate concentration measurement. So some more examples you might see are, alcohol and water, sugar and water, acid and water, caustics, bases. So we'll see some example of these here moving forward. So this graph here, it's depicting, you have the density on the x-axis, and then you have the concentration on the y-axis, and then the different colors represent different temperatures. So you can see by monitoring the density and the temperature, then that's how we are able to correlate that to the specific concentration. So what does it look like on a device level? So if you order one of our Coriolis meters with the concentration package that's actually built into the model code, it's something that you have to select. It doesn't come as standard. You'll see that when you go to set up the meter, we have predefined mixtures in our concentration package. So you can see that we have, sucrose and water, we have ethanol and water, sulfuric acid, we have salts. And then along the bottom there, you can see that we do have a percent mass and percent volume. So what that means is that if your mixture or solution is not one of the predefined that you see there in this list, we can actually help you create your own data table and data set and then put in custom coefficients. And you'll see that at the bottom, we actually have 3 separate coefficient sets. So those are 3 custom coefficient tables. So if you're going to be having 3 different solutions, switching, running between the same Coriolis meter, you can actually store up to 3 coefficients to use for each of those solutions. And once you select one of those, the liquid types, depending on what you select, these are the standard units that we offer. So again, you can see the degrees Brix, you can see Plato, you can see, balling and things like that. But then you might also notice that we have user concentration or a user concentration unit. So if you want to have a custom one per se, you can actually type in and say, okay, I want it to be X, Y, or Z. So very customizable. And some of the new updates that we've done is with our newer concentration package, we no longer use data tables. So we use direct formulas. So this comes straight from the ICUMSA, and you can Google this as well. And here is the standardized formula to analyze sugar analysis, pretty much, sugar concentrations. So you can see that for a percent mass or just the Brix, you can see that it's calculated directly from the measured density and the temperature. And so what does this really mean? So in the past, traditional Coriolis meters, they would have tables built into them inside the electronics. So for example, you can go look at sucrose and water, a data table, and you can see it shows densities, temperatures, and then the associated concentrations. Now, at the end of the day, if you're using data tables, you're going to end up with some sort of approximation error. But now that we use the direct formula inside of our meter, we no longer have approximation error. So, we can sit there and say that, but what does it actually mean in terms of the accuracy of our measurement? So on our website, publicly available, we have a sizing program that's called Applicator. And we have a specific module for sizing and selecting concentration measurement. So for example, you can see here in this example, I chose a liquid concentration of aqueous sucrose. And I put in on a mass basis from 0 to 100%. You put in your temperature and your pressure, and then you can see it's water and aqueous sucrose. And then at the very bottom on the right-hand side, you can see what the error would be. So in this case, we would be at a 0.05% mass or 0.05 degrees Brix. Now, of course, that'll change depending on what sensor you choose and what concentration target range you choose. For example, if we did just a 0 to 50% instead of 0 to 100%, that would change. But this is available on our website. You can go and use this and play around with it. A very cool feature. So we didn't only do this for Brix measurement. We also did this for proof and alcohol measurement. So again, there's a direct formula inside of our transmitters. It's the Bettens-Bewick formula that was formulated in 1990. And you can see there, it's a very long equation. We don't need to go into detail about what every part of the equation means. But at the end of the day, you can go into our meters, and what you're seeing here is a screenshot from an integrated web server, which is included in all of our Coriolis meters and most of our flow technology, actually. And you can see that you set it up for ethanol and water, and then you get a list of units. So we get ABV, alcohol by volume. You can do it in proof terms, or you can just do a percent volume or percent mass. And so what I've done is I've set it up for proof, and then you can see a simulated display of the meter showing that, you know, we're measuring 75.42 proof. And again, you know, this web server is built into all of our flow technologies. You don't need any special hardware or software to access this. And Ola specifically mentioned this application earlier about this percent overrun measurement. So what it is the overrun is the amount of air in whipped product. So the amount of air that's injected, let's say into, you know, a whipped yogurt, or, you know, the big one is ice cream. It's probably the most difficult. So Anderson-Hauser has put together a complete solution to measure the percent overrun using our Promass Q Coriolis meter. And then we also have 2 pressure transmitters as well. And then we have a PLC that's able to run all the calculations based on the measured variables from the Coriolis and the pressure. So again, you know, the density of the liquid mix is going to be determined before the gas injection based on, you know, the Promass Q. And then by measuring the inlet and outlet pressure, we're able to determine how much air is actually in there, and then with the math functions in the PLC provide that measurement. And we do have one of the handouts that Nikki mentioned, specifically detailing the solution and how we accomplish it. And we also have some references that we can share if you're interested. So I mentioned earlier about the custom mixture. So for example, here's just a sodium chloride and water concentration table. So you can see you have density, temperature, and then the actual concentration. And what we can do is we can run calculations and determine these density and temperature coefficients that you see on the right-hand side. And so you can store those and input those into the meter. And then at the end of the day, you can then see what sort of expected uncertainty you would expect to get. So you can see that the dark blue in the middle is kind of the, you know, approximated error. So pretty much almost less than 0.1%. And then we have a worst case positive and a worst case negative. So again, if you have any custom mixtures that that's not included in the predefined liquids or solutions, we can help you and work with you to run these custom tables to give you an expected error and then help you input those into the Coriolis meter. And the last thing I want to touch on here is heartbeat technology. So pretty much heartbeat technology has, you know, 3 kind of facets. So what it does, it ensures consistent measuring performance. So looking at the quality, safety, and availability of one of our devices. So what actually can it do? So it starts with one of our Coriolis meters. And then the first pillar underneath the umbrella of heartbeat technology is heartbeat diagnostics. So this is continuous self-monitoring that the device is performing on its own. And we have diagnostic symbols that were designed according to NAMOR NE107. So you can think about it like the kind of the dashboard on your car. So if you have a flat tire, or, you know, a critical failure, or the battery's dead, our devices, according to the severity of the diagnostic, the screens will actually flash red if it's a critical failure, or it might tell you it's out of specification if your 4 to 20 output is, you know, ranged, you know, incorrectly, or something like that. So moving forward to the right, probably one of the most exciting pieces of heartbeat technology is the verification itself. So this is an onboard self-verification in the device that can be ran on demand without process interruption. And at the end of the day, when you run a verification, you can then pull the verification report in PDF format directly from that integrated web server that I showed earlier. And this verification is attested by a third-party TUV to ensure, you know, ISO 9001 traceability. So, you know, we can state whatever we want about heartbeat verification, but we went the extra mile to that third-party TUV, and we have all these attestations depending on what technology and sensor it is. So if you have any questions or if you need one of those, please let us know and we can provide those. And then lastly is heartbeat monitoring. And I'll get into some more details on this, but this is really giving you a window into your process and can help you with preventative maintenance. So you can look at buildup or corrosion or erosion, and heartbeat monitoring allows you to output some of those specific sensor test points that are tied directly to some of these process impacts. So looking at the three of these again, we have the diagnostics, which is the continuous testing and the error messages, and they even provide remedy-based diagnostics. So it'll actually tell you to check for gas in your process or check your wiring and etc. And then the verification and the monitoring. So the diagnostics piece is standard on all of our flow devices, and then the verification and monitoring come together in a package that's optional. So very similar to the concentration package I talked about earlier. And some of the really cool things, I just wanted to show you some cool examples here of the heartbeat monitoring. So we have a value from the sensor, which is called the heartbeat sensor integrity, or HBSI. And by monitoring the HBSI, you can kind of get a window into the process to see if you have any of these impacts happening, like if you have entrained gas or suspended solids, corrosion, cavitation, etc. And so what you can see here is we have the HBSI value along with flow and density. And this was an example on hydrochloric acid. And you can see what happened was the density started to shift. Then the HBSI and the flow started to shift as well as the corrosion level increased. But really, just by monitoring the HBSI along with flow and density, you would have been able to have seen a shift very early on instead of having to wait until you saw an 8% shift in density, etc. And so, looking at it in terms of coding, so, when the HBSI value was intact, we saw barely a shift at all of 0.0023%. But then when we had actual fouling occur, you could see a noticeable shift of, almost 1%. So just to wrap it up, what makes heartbeat technology unique? So the reliability aspect really comes to the traceable and redundant references that are inside the device to perform that verification attested by a third party. And, so how do we get all this data from the device itself? Well, we do offer a full range of digital communications on our not only our flow technology, but really across all of our technologies. So level, analytical, pressure, etc. So that's looking, we have HART, we have Modbus, and then we also have Ethernet IP and Profinet. So, especially using Ethernet IP or Modbus, you're able to very easily pull all this data from the device. And then this is consistent across, like I mentioned, not only our flow portfolio, but actually across all of our technologies. So this heartbeat technology with the diagnostics, the verification, monitoring, you'll see that across all of our principles. So that concludes the presentation. So Nikki, do we have any questions?
Okay, great. Thanks, Adam. Yes, we do have a few questions that have come in. So first question, what kind of accuracy can I expect if I use for an HFCS 42 Brix measurement?
Adam, do you want me to answer that one? I can pick that
Sure.
one up. I think
Sure,
you actually touched on it. You actually had one of the slides in there that looked at that a little bit there. So HFCS, I believe that's high fructose corn syrup, and 42 Brix is a very typical Brix value for sugar. And I would say you would get approximately a 0.04 Brix tolerance on that measurement.
Okay, great. Next question. How much does temperature affect concentration measurement?
Yeah, so I can take that one. You might have remembered that slide, or the graph I had in there showing the different temperatures, against the density and concentration values. So temperature is going to have a huge effect on the concentration measurement. I mean, it's hard to just put a general number out there, but I mean, it could be anywhere from 5% to more than 50%, depending on the temperature swings, etc. So if you're trying to compare the live concentration measurement from our Coriolis meter to, let's say, a lab value, that lab value is most likely going to be at a different temperature than the process is at. So inside of our Coriolis meter, we can actually input in a reference temperature to take the live concentration measurement and correct it back to a known reference temperature to match your lab. So hopefully that answered the question.
Okay, great. And can all of the Anderson-Hauser Coriolis meters measure concentration? And is there a special package that you must purchase to do this?
Yes, so that's a great question. So all of our Coriolis sensors have the ability to measure concentration. I mentioned that all Coriolis meters measure mass flow, density, and temperature. And those are really the three legs of the stool that you need to come to a concentration measurement. And I talked about it earlier, but there is a concentration package that must be selected when ordering the meter, or if you have an existing Coriolis meter from Anderson-Hauser, we can very easily add the concentration package after the fact with a quick software code, and then you'll be up and ready to measure concentration.
Hey, great. Next question. Does Vector offer any type of training on this technology?
Yeah, I can take that. Yes, we have a great program called Vector University that we offer classes, comprehensive classes around all the different instrumentation technology, but specifically as it relates to Coriolis, we have classes that can take you from basic Coriolis all the way up to just understanding how the technology works, all the way up to troubleshooting and diagnosing and working with the Coriolis meter. We are in the process of building a 112,000 square foot facility in Pearland, Texas that's going to also have what's called a process training unit in it, where we'll be able to hold in-person classes, and students and instructors will be able to get their hands on to devices and actually work with them, use them, and see how they work. If you want, Nikki, I can share my screen to show that real quick.
Okay.
Well, no, it's not letting me, but that's okay.
I can come back to that. I will ask another question and I will give you controls, Caleb, to go ahead and do that. Next question was, can I add concentration measurement to my existing Anderson-Hauser Coriolis meter?
Yeah, so Nikki, I'll take that one. I touched on that already. So with our newer Coriolis meters, we can easily add concentration, the concentration application package after the fact with a simple, pretty much activation code. And if you have one of our kind of older Coriolis meters, we can also still add the concentration package after the fact, but it does include a little bit of hardware as well with it, not just software. But the short answer is yes, definitely.
Okay, great. Let's see here. Next question. Can I measure milk fat concentration during milk receiving?
You want to take that one, Ola?
Yeah, sure, I can take that one. The answer is essentially no. I think Adam touched on it and I touched on it. So if you're trying to do milk fat concentration, if you're doing it, let's say after the separator, so you're looking at the cream, or where any air bubbles have dissipated from the milk, then yes. But the specific challenge during milk receiving is that as the milk is arriving at the dairy plant, there's usually a lot of air bubbles into it, and trained micro bubbles in the milk. And so now you essentially have three variables that would potentially affect the density. So you have the milk fat, the fluid or the milk, the skim milk itself, and then the air bubbles. So that would make it very difficult to get a good accuracy of a milk fat at that measurement point. Anywhere after that in the dairy where the air bubbles have had the opportunity to dissipate, then milk fat concentration is absolutely possible. Actually, throughout the market, many skid builders and so on are actually using the Coriolis meters for milk standardization skids, where concentration or density is a critical variable.
Okay, great. So Caleb, I gave you presenter mode. So I'll go ahead here and let you talk about our new PTU training facility, and then maybe also touch on our any of our on-site service capabilities, because that was another question that was asked.
Sure. So this is a rendering of what the PTU is going to look like. It is in the process of being constructed right now. We do have access in the meantime to a PTU that's somewhat like this at the Greenwood facility for Anderson Hauser. So you're going to see lots of different tanks, vertical tanks, horizontal tanks. To my understanding, that they can kind of reconfigure this system depending on the class and how they want it. But there's going to be PLCs and controls and valves and all sorts of different devices to be able to get their for students to get their hands on and get real world understanding and training. We also do have the capability for our service techs to come to your site and do calibrations. I know that in the food and beverage industry, calibrations are critical. And we do have on-site capabilities for that. And then for larger, above 3-inch meters, we can do, Anderson Hauser has the capability of doing calibration for those meters too at their calibration rig.
Okay, well, that actually concludes all of our questions that we had from the audience. Just a reminder that we do have those handouts available, and you can download those for your own reference now. And we'd like to thank everyone for joining us. We trust that it was a worthwhile experience for you and you learned some valuable takeaways from our experts. I'll turn it back over to Caleb for final comments and closing.
Thank you everyone for your time. Really want to thank Ola Westrom and Adam Booth for their presentation and for the information today. Feel free to reach out to any of us if you want more information or if you have any applications that you have yourself or a client that's struggling with. Thank you very much for your time. Have a great afternoon.
Yep, same for me. Thank you.
Yes, thank you everyone.